here today who's going to talk about energy with us. His name is Colin Kelly, and he's the director of the Department of Applied Research at Confederation College. So today, as you know, is Energy Day. We're going to be building some Rube Goldberg machines, and we've already been doing some practice here in Ancaster. So we have lots of questions about energy. But before we get to those questions, maybe Colin, can you tell us a bit more about what you do and maybe how you work with energy at Confederation College?
Sure. What I'd like to talk about is a renewable energy project we have on the go here and what we'd like to do with it. It's brand new, so we're pretty excited. I've got some slides I'm going to do. We were out yesterday. I was hoping to be able to walk around. I'm talking to you with an iPad. And I was going to basically give you a walkthrough tour on the iPad, but we were having Wi-Fi issues at our end. So I'm in my office, and hopefully these pictures come through, so you let me know. The renewable energy we're interested in is biomass or wood chips, and I'll talk about that shortly. So hopefully you can see that picture.
Yeah.
Okay. So there's a solar panel that most people are probably familiar with, and a couple of windmills, a vertical axis windmill and a more traditional type windmill that most people are familiar with. So we have those renewable energy technologies on site here. And another renewable energy that I want to talk about is biomass. That's a picture that's right out of my office here. In Thunder Bay, we're in northern Ontario in the far northwest, and we're right in the middle of the forest. So as you can see, we have lots of trees literally right out the window of my office. So that's why we're interested in looking at trees as an energy source. This is a new building that we built, and I hope to take you through with my iPad as Wi-Fi issues.
Okay, I think they're on mute now, so we'll be able to hear you if you'd like to continue. Sorry about that.
Okay, so I was just talking about how we have a renewable energy project on the go here in Thunder Bay at Confederation College. We do have wind and solar, like most people are familiar with, but also we're interested in biomass because we're in northern Ontario, right in the middle of the forest, and that's a picture right outside my window. So we built a new facility. This is the front end of the facility. The door on the left is where we will be loading wood chips. This is all brand new, and the door on the right is where the biomass boilers are that are going to be used to create the energy. Right now, it's just heat energy to heat our main campus building, but we're looking at generating electricity from it in the next phase. This is behind the left-hand door. It's just a big empty bunker, we call it, that'll be filled with wood chips that get dragged to the back wall. And then here's the other side of the building, some brand new, very highly efficient biomass combustors, basically fancy wood stoves that burn the wood chips to extract the energy from them, much like the windmill turning creates energy, or the solar voltaic cells, the solar panels create energy from the sun. We create energy from burning the wood, which if you think about it, plants grow by capturing the energy from the sun. So in a way, this is sort of another version of solar energy because we're releasing the energy that the plants captured by harnessing the energy of the sun. This is some other technology on the building. We also want to incorporate other renewable technologies. This is a green roof. You could see, a regular sort of black roof with a green patch. The green roof or living roof is actually what it sounds like. There's plants growing on top of the roof. That helps keep the roof cooler and helps absorb moisture. So we have sensors underneath the green part and sensors underneath the black part. And we're going to compare how the roof performs in terms of cooling the building, actually keeping it warm in the winter, and collecting some rain runoff so there's less stormwater runoff from the roof. We also have what's called a solar wall. So you can see that black part just above the bricks, the brown bricks. That heats up in the sun, and that hot air goes into those big wood ovens, those biomass boilers that you saw before, so that we don't have to burn as much fuel to heat the air. This makes it much more efficient. what we're interested in, these are the stacks coming out of the top of the building. As you know, fireplaces and wood ovens, wood stoves have chimneys. These are the chimneys for the wood boilers that I showed you earlier. You can't really see because of it's a picture, but down below you can see all those little holes and black spots. Those are areas where we can insert probes to make sure that whatever's coming out of the stack is clean. We don't want any pollution. The good part about using wood as energy is it's very efficient. It's carbon neutral. In other words, it reduces greenhouse gas emissions. So if we were burning natural gas, for example, we'd be adding carbon dioxide to the atmosphere. When you burn wood, the theory is that the tree that you cut down or the branches that you cut off to burn are regrowing in the forest. So there's no carbon dioxide that's actually added to the atmosphere because whatever comes out of the chimney is absorbed by the new plants that are growing. So that's one reason why we're really excited about renewable energy, is to minimize our carbon impacts. But also we're interested in the research behind it. So we want to make sure that our boilers are operating as efficiently as possible, and we can do that analyzing the stuff that comes out of those stacks. We want to do research on the sustainable side so that we know that our forest is operated sustainably, so that we know we're not cutting. Sorry, can you see me? There I am. So we want to know that we're harvesting the wood sustainably, so we're not cutting too much down that can't grow back. We want to be able to look at community development impacts of biomass, because a lot of our communities need employment. So this is an opportunity, rather than paying your money to the electricity bill or to an oil company, you employ local people to gather the wood for you. So it's an opportunity to create jobs. We want to research that. So I know I've only got about 5 minutes and I'm getting pretty close. So the research side, we're looking at everything, right? We're looking at opportunities for new jobs for people. We want to make sure the air that comes out those stacks, those chimneys, is very clean. And we want to make sure that whatever wood we're using to harvest, whatever wood we're harvesting to burn, we're doing so sustainably. So we're not, in other words, we're not cutting faster than the forest is growing. In fact, what we're burning here on campus is actually all the waste wood that's created by Thunder Bay Parks and Ontario Hydro when they trim all around the power lines and when they clean up parks. All that wood now gets shipped to the college, whereas it used to just go to the landfill. So maybe I should stop there and folks can ask me any questions that they'd like.
Okay, great. Thank you very much. Why don't we start with a question in Woodstock first? We'll just wait for them to come up to the mic.
How was electricity discovered?
How was electricity discovered?
Yeah.
Actually, well, I think most people credit that to Benjamin Franklin, an American in the late 1700s who was flying a kite in a storm and noticed the electricity.
Okay, thanks. Good question to start with. Why don't we go to London for the next question?
Okay, next one.
Hi.
What does energy do?
Well, energy can do, that's a good question. Energy can do a lot of things. In our case, what we want the energy to do is heat our main campus building. It's about 40,000 square meters, so it's a big building, and it gets awfully cold in Thunder Bay in the winter. So in that case, energy is going to keep us warm. You heard the question about electricity, so energy can also do things like light a light bulb or make motors work, like a fan, to keep you cool in the summertime, or to keep the air conditioning running. So energy can do lots of different things.
Okay, great. So Braden here in Ancaster sort of has a related question he's going to come at. You can look right into here.
How do we use energy?
Thanks, Brayden.
Well, we use energy almost every day. Like for our project, we use energy. We were talking about mostly heat energy for the winter time. So we use energy to keep the buildings warm in the winter. We use energy to keep them cool in the summer. We use energy to power your computers. Energy's running my iPad right now that I'm talking to you on, and you're looking at a big screen in the classroom. That takes energy to run the screen and make the screen work. Energy can mean everything from like the trucks that bring the groceries to your store. They need energy to go to and from the farm to the store, and the energy is usually gasoline or diesel fuel. So it comes in many different forms, but it's something we need to use every day. And that's important because if we're using energy every day, that means we're having impact on the environment. So what we want to do is minimize that. So when you burn gas or you run electric motors, usually you're going to be emitting greenhouse gases in order to do that. It's going to make the earth warmer, and we don't want that to happen. So that's why we're looking at things like renewable energies, like biomass, like wind and solar energy, so that we can reduce our impacts on the environment.
Great. Lots of important things to look into, research, and keep in mind. That's awesome. So for the next round of questions, let's go back to Woodstock.
Does energy move?
Sorry, I couldn't hear you.
Does energy move?
Does energy move?
Yeah.
Well, yes and no. Like electrical current moves through the wires from one spot to another, but you can't really see it move. But what energy most people usually associate energy doing is it makes other things move. So gasoline, for example, makes your car engine run, and your engine makes the car move. Sometimes you can see energy moving, like with a windmill, for example. You see the blades, the turbine, spinning like a fan. So in that essence, you can almost see the energy moving. Other things like a solar panel, you don't see a lot of movement. It's just sitting there in the sun, and you can't see anything exciting happening, but it's still making energy.
Great. Okay. Let's go to London next. Hi.
Where did energy come from?
Well, it comes from a lot of different sources. What we're most interested in is energy that comes from the sun, because that's usually the cleanest type of energy. If you're digging the energy out of the ground like coal and oil, that tends to have a lot of pollution associated with it. If you're using energy that basically comes from the sun, like solar energy or wind energy, because it's the sun that makes the wind essentially, or biomass, because it's the sun that allows trees to grow, those types of energies are much cleaner, and that's why there's a lot of interest in renewable energy, they call it, solar and wind and biomass, and there's other examples, so those are the big three.
Okay, great. So we have campers here with another question for you, Veronica and Max. They want to know, you guys can read it.
What? What are forms of energy?
Sorry, I couldn't hear that. It was a big echo.
What are forms of energy?
Well, there's lots of different types of forms of energy. I'm not sure what exactly the question is in relation to. Maybe you could help me out.
Do you want to know where all the different places energy comes from? They mean like what are all the different forms of energy, like where the sources come from?
Oh, that's a big question. I mean, maybe we'll start with the renewable energies. So, because that's what, the project I was talking about. Most of that energy comes from the sun, either so you can have solar panels that take the sun's energy and directly make it into electricity, or the sun causes wind because it heats up the earth in different ways. So then that creates wind because some parts of the planet get hotter than other parts. And so when that happens, wind is created. The sun also allows plants to grow, and they store the energy as wood. So when you burn the wood, you release that energy. So as I mentioned, that's why it's important that we're looking at renewable energies that are usually linked to solar as the cleanest way to go. There's other forms of energy too, like you could burn gasoline, or you can burn coal, or you could use nuclear energy, but they all generally have more impacts on the environment than energy sources that are directly linked to the sun.
Okay, thanks. So we have time for one more question. I want to go back to London for the last question. I see a hand up. Oh, hi.
I was wondering, can you combine two types of energy to make a new energy?
Can you combine two different types of energy?
Yeah, to make a new energy.
Well, sure, that's kind of what you're doing when you're looking at things like renewable energy, because you're taking, say, solar energy, and then you can change it into electricity, or you can change it into heat, or you can change it into both. So that's one thing you're doing with energy, is you're constantly sort of changing its form from one to the other.
Okay, yeah, that was a good question.
Yeah, very good question. And
yeah.
you could also combine all these technologies, which is what we're looking at too. So you can have a windmill, and you can have solar panels, and you can have biomass energy all working together, so that you have the energy that you need when you need it.
Very cool. All right, so that's all the time we have for our call today with Colin Kelly from Confederation College. Thank you very much, Colin, for taking the time to call into STEM Camp today and answering all our questions about energy.
Thank you very much for inviting me. I hope to get an invite again next year.